The lifeblood of a democracy is your ability to understand and act upon a problem once the facts are presented to you. The purpose of this motion picture is to give you the facts, and then you, as individuals and citizens of a democracy, must take action.
Every culture on the planet Earth is always changing, sometimes rapidly and sometimes very slowly. These changes occur in different ways. One is through diffusion of culture traits from one culture to another. The primitive native quickly adopts many of the advanced culture's tools, whose value is readily apparent to him. On the other hand, primitive culture traits like the Indian maize are quickly adopted by the advanced cultures who see value in them.
As the science of agriculture advances, the world will be better fed and clothed and housed. You too will reap great harvests.
Today, agriculture is going far beyond nature to produce new miracles for an even better, more abundant life. On the farm today, wherever you look, you see the handiwork of scientists. Improved crops, more productive soils, more useful, more efficient machinery. They are the result of a miraculous agriculture.
Wholesome, wholesome, wholesome goodness, wholesome, wholesome, wholesome goodness, wholesome, wholesome, wholesome goodness, productions. Present.
In the harvest of 1999, 60% of Canada's canola crop was genetically engineered, 90% of Argentina's soybean crop, 50% of the U.S. soybean crop, 33% of the U.S. corn crop was genetically engineered.
Industrial agriculture is damaging the basis for future production. We've got soil erosion, soil compaction, salinization, waterlogging, destruction of beneficial biodiversity, loss of natural enemies of pests. That's really occurring at an alarming rate.
Three things needed to come together to make the Green Revolution work. One was the development of specific high-yield varieties and often dwarf varieties of wheat or rice, and also corn that were derived by special outcrossing and hybridization techniques that Norman Borlaug perfected working in Mexico and also in the southwestern United States. Secondly, there was a tremendous investment of funds from the Rockefeller Foundation and the World Bank to assist poor countries to develop a broader food base based on these resources. And then third, there was a tremendous availability and input and requirement for pesticides, fertilizers, and irrigation, which combined to reinforce the value to American commerce of supporting this type of agriculture.
The Ford Foundation and the Rockefeller Foundation in the 50s were concerned that if the issue of hunger in the Third World wasn't addressed, then poor people in those countries would be ripe for communist subversion.
The Green Revolution, which is really the introduction of chemical agriculture under forced circumstances to countries like India, was basically created as an antidote to social change. It was meant to reinforce patterns of inequality, which it did. The smaller peasants lost their land because they could not afford to keep up with the credit payments linked to the Green Revolution. The intensive water use has left large tracts absolutely desertified. The agricultural diversity that fed people has been wiped out. And yes, the production of rice and wheat has increased, but that is not an absolute increase in food. The production of legumes, of dals, of chana, of chickpea, of oilseeds, of mustard has all come down.
Faced with the choice of crop failures and resulting worldwide starvation, the use of pesticides and herbicides seems inevitable.
If we talk about pesticides specifically, they came out of the defense industry. The first modern synthetic chemical pesticides were derived from nerve gases developed by the Germans in World War II. And they found that by some simple changes in the molecules, instead of having their greatest toxicity be for human beings, they could have their greatest toxicity be for insects.
There were plenty of chemical factories left over from World War II. We got a raft of secrets from Nazi Germany that allowed us to make organophosphate pesticides that we did not have the capacity to make before. My uncle was in the intelligence service in the Army and went to the IG Farben plant and got all the chemical secrets that they had for making organophosphates as well as plastics. And this in part contributed to a great expansion in our knowledge base for making chemicals that could be used in the pesticide industry.
Through the chemistry of explosives, that connects directly, because of the chemistry of it, with the chemistry of fertilizers. And then coming out of the war, you have a whole infrastructure of industrial capacity that was war-oriented, with nothing to do.
The impression I have is that chemical agriculture became the norm when it was clear that the progressive addition of rounds of fertilizer amendments to soils that are chemically based, coupled with pesticide regimes that suppressed weeds and also controlled insect pests, worked best on large-scale operations where you could mechanize production and use aerial application of the pesticides. The chemicals that are used for pest control historically through the 1950s and early 60s were, by design, chemicals with long environmental persistence, like chlordecone, DDT, chlordane. Those are major chlorinated chemicals that have half-lives measured in decades rather than months or weeks. The idea was that they build up a protective barrier in the soil against repeated infestations. Virtually all the chemicals I just listed have been banned and have terrible environmental consequences because of their persistence, their ability to concentrate up the food chain, and their concentration in food crops, particularly crops that have a heavy oil base like corn and others.
The whole mentality of industrial agriculture is really similar to the whole mentality of war. Humankind against nature, man against nature, and using the same kind of weapons that we use to dominate people in warfare.
One of the newest and most versatile weapons in Dow's arsenal of chemical warfare.
And I think we can contrast that to the alternatives to organic farming or more agroecological approaches, which are gentler techniques, which don't involve the domination of nature, but really the living with nature.
There's a USDA study from information they got in 1998 that showed that the average revenue per acre on a farm larger than 2,000 acres was, this is per year, was $21.40 per acre for a year on a large-scale farm. However, the average revenue per acre on a farm of 10 acres or smaller was $1,960. And
on our farm?
On our farm, it's probably somewhere around like $15,000, $16,000 per acre.
One of the reasons why large farms are relatively unproductive compared to small farms is that large farms the world over tend to use monocultures. A monoculture is a single crop species planted over a very large area, and large farms have to use that unproductive farming system because their size means that they have to mechanize a lot of their operations, and it's difficult to mechanically plant or mechanically harvest more than one crop. Yet that's terribly inefficient.
The idea that the average production on a larger scale farm, the average revenue for a year is, a little more than $20. I mean, how the hell can anybody possibly make a business out of that? And the answer is by having hundreds of thousands of acres.
So I guess the point that becomes really important is the fact that we believe that small farms are not efficient is because they do not have the subsidies. Whether these are farmers in third world countries like the Philippines or Mexico, or these are small family farms in this country, they're all on the brink of extinction because the subsidies that should be provided to them, the support that should be provided to them, is all being channeled to big agribusiness corporations.
Let's see how the system works.
The way the system works, in essence, is that it works to keep the prices low that farmers receive for what they produce, while subsidizing the corporations like Cargill or like Archer Daniels Midland or Continental Grain that take U.S. farm products and export them so that they can put them onto the global market at prices that can undercut farmers anywhere else in the world.
You see, Tommy, with the tools we have today, farmers all over the country can produce great surpluses.
Since we continuously have a surplus of many of our grains, and we have the lowest commodity prices in probably 15 years presently, the question is, why do we continue to insist that we need a second green revolution, the biotechnology revolution, in order to feed the world?
Thus, agricultural research in colleges, industry, and government goes forward. Result, new products, new businesses, more jobs. Help yourself to a miracle.
New hope in the battle for control.
Yes, well, we've come down to Safeway. It's one of the world's biggest supermarket chains, to try and get the message across that they should not be selling genetically modified food. I come from England, one of the countries where there's been a very big campaign on this whole issue. And really what we're saying now is that, you know, we need to stand back from this unnecessary and very dangerous experiment.
I think the main concern here is that the genetically engineered food, Safeway is GE-free in Europe, and they haven't even begun to label in the U.S., which is somewhat of a concern and double standard for Europeans and United States citizens.
Genetically engineered foods could be having effects on people right now, but because they're unlabeled, no one would know.
Biotech is an incredibly broad subject area. Really, if you take the textbook definition, it's the use of living organisms or components thereof to make useful products, processes, and services.
All the food we've eaten all our lives, that our parents have eaten, and our grandparents have eaten, and so on, it's all been genetically modified just by various kinds of techniques. Many consumers would be surprised to find out that our modern tomatoes are derived from an ancient predecessor that was a tiny berry. In fact, that was quite toxic. It's through literally hundreds of years of selective breeding, that is, genetic modification, that we have the modern tomato.
What we're talking about is the extraction of genetic material out of a reproductive context. A context that has been evolving with this piece of DNA over millions of years, taking it out, manipulating it as a chemical, and then putting it back into another reproductive context where it's going to operate in a different way. This type of manipulation, the transgenic manipulation, really has no precedent in history or in evolution.
Here, in fact, is the answer to a dream as old as man himself, a giant of limitless power at man's command.
The beauty and peril of genetic engineering is that you can move genes from as far distant a species as a flounder into a tomato to ensure that you have a plant that's tolerant to very low temperatures because of antifreeze genes that are present in the flounder.
But you could find that same gene in any number of other organisms. It was just easier to take it from a flounder than it was to take it from another plant. But you'll find those genes in plants as well.
That type of engineering is made possible by the universality of the genetic code, that plant or animal species can read each other's genetic messages.
And in fact, you and a pea and a cow have all about 60 to 70% of your DNA is very similar. You're much more closer to these organisms here than you might think you are, because an awful lot of the basic housekeeping genes are very, very similar.
The FDA considers them to be the same as traditionally bred crops, so there's no label required, there's no testing required, and we really don't know what's going to happen.
It's an outrage. A man isn't safe even at his own dinner table.
Something ought to be done about it.
Why doesn't the government step in?
In theory, the government has 3 agencies that could regulate biotechnology-generated agriculture. The first and foremost would be the Food and Drug Administration, but it decided beginning in 1992 to allow the deregulation of these crops from its point of view because they were equivalent to existing plants and foods.
A very convenient tool called the substantial equivalence principle was cooked up to say, let's just treat genetically engineered organisms like conventional crops. Of course, they don't say that when they want to patent those same things. Then at that point they say, these are novel, these are not natural. But when it comes to safety, they say, just like nature, exactly as nature made it. I sometimes call this ontological schizophrenia.
FDA, under the regulations as they exist at the moment, are only obliged to label if, in fact, there is a potential problem with respect to safety and efficacy. Now, how the products of biotech are produced is actually a process. That's not a product in itself. FDA do not have any capability or any regulatory authority to actually label based purely on process, and I think a lot of people don't realize that.
Secondly, the U.S. Department of Agriculture could regulate these plants as they would any new plants. They decided that these plants did not comprise a new category of plantings compared to other hybrid type varieties that are already on the market.
Sound science has demonstrated time and again that many biotechnological advances are safe and reliable. But if consumers at home and abroad don't share our confidence, they will reject genetically treated products, and we won't be able to get a return on the enormous public and private investments that have been made in biotechnology.
Then the EPA has the opportunity to regulate plants that might pose new environmental risks or would pose risks because they themselves, the plants, have pesticides in them.
Rather than creating a new regulatory framework or new laws, there was a decision made, a recognition that existing laws could be applied to this industry. And at that time there was a term and a construct that was coined that is called the coordinated framework, and that refers to what is supposed to be a viable, effective, coordinated effort among those 3 agencies.
So we have 3 different agencies, each one, in my viewpoint, only half-heartedly or not at all, taking an aggressive regulatory posture to control this industry.
There's a reason we have confidence in the federal bodies that analyze the safety of our food. They may not be perfect, but nobody believes they're in anybody's hip pocket. They're the world's best experts. We have an orderly, disciplined system here.
Terry has global responsibility for biotechnology, regulatory, public policy, and external affairs for DuPont Nutrition and Health. He was formerly the APHIS administrator here in USDA. And might I add, Dr. Medley, it's nice to see that this professional life beyond government.
We must continue to argue in multilateral forums like the WTO that our biotech products have withstood the strictest scientific scrutiny.
It's nice to see that this professional life beyond government.
What do we want?
Based on our experiences, the existing FDA guidelines have been transparent, effective, and have functioned to assure the safety of our food supply.
The consumer certainly has a right to know what is in his or her foods, but
sometimes rapidly and sometimes very slowly. These changes occur in different ways. One is through diffusion of culture traits from one culture to another. The primitive native quickly adopts many of the advanced culture's tools, whose value is readily apparent to him. On the other hand, primitive culture traits like the Indian maize are quickly adopted by the advanced cultures who see value in them.
As the science of agriculture advances, the world will be better fed and clothed and housed. You too will reap great harvests.
Today, agriculture is going far beyond nature to produce new miracles for an even better, more abundant life. On the farm today, wherever you live,
the lifeblood of a democracy is your ability to understand and act upon a problem once the facts are presented to you. The purpose of this motion picture is to give you the facts, and then you, as individuals and citizens of a democracy, must take action.
Every culture on the planet Earth is always changing.
Look, you see the handiwork of scientists, improved crops, more productive soils, more useful, more efficient machinery. They are the result of a miraculous agriculture.
Wholesome, wholesome, wholesome goodness, wholesome, wholesome, wholesome goodness, wholesome, wholesome, wholesome goodness Productions present
In the harvest of 1999, 60% of Canada's canola crop was genetically engineered, 90% of Argentina's soybean crop, 50% of the U.S. soybean crop,